All right, measurement review. So we're going to start off with how many centimeters around a 400-meter track? Question 1A. How many centimeters around a 400-meter track? Notice how lazily we write out what the question is. So we're going to start off doing it the grade 8 way. Over equals over. So we're going to start off by putting 400 meters wherever we want. So we're just going to put it here. So now, off to the right, we're going to write down the conversion factor that we know about centimeters and meters. Now, we know there's 100 centimeters in 1 meter. We have to put 100 centimeters on the top and 1 meter on the bottom, obviously, because we decided to put meters on the bottom. Now we're going to put an arrow from the 1 to the 400, and we're going to ask ourselves, how do we get from 1 to 400? We're simply going to times by 400. Now, we're going to put an arrow from the 100 to the left, and recognize that we're going in the same direction, so we're going to do the same operation times 400. Now, 100 times 400, 1 times 4 is 4, and we have 4 zeros. 40,000, and let's say centimeters, and circle our answer. So that's the way we're going to do it, the old way. Now we're going to do it the better way. So we're going to start off with what we're given, 400 meters on the margin. And we're going to multiply by a conversion factor over. Now, we're going to wait and think. We need to multiply by a conversion factor that allows us to cross off the units we want and get to the cross off the units we have and get to the units we want. We have meters, so we need to put meters on the bottom. And we need to get to centimeters, so we're going to put centimeters on the top. Now we know that there's 100 centimeters in 1 meter, so we're going to put 100 on the top, and we're going to put 1 on the bottom. And notice we're just going to do 400 times 100 divided by 1 is just the same 40,000 that we got before. Now we're going to cross off our units that we have and circle the units that we want. Exactly, let's circle our answer, 40,000 centimeters. Perfect. So we're no longer going to do over equals over, equal fractions like we used to. We're always going to do conversion factors. Okay, how many inches in 1 meter? So we're going to start with what we're given, 1 meter. Then we're going to times by a conversion factor over. We need to cross off meters, so we're going to put meters on the bottom. Now, can we get straight to inches from meters? Well, sure we can, but let's do it separately. So let's go to centimeters first. So we're going to put centimeters on the top. We know there's 100 centimeters in 1 meter. And we're simply going to times 1 times 100 divided by 1 is simply 100 centimeters. Now, we could carry this 100 centimeters down onto the next line, or we can just go straight from here, times, over. Now we need to get the inches from centimeters. So we need centimeters on the bottom and we need inches on the top. And we know that there are 2.54 centimeters in 1 inch. Notice the number goes on the bottom this time. Now, 100 times 1 divided by 2.54 is 39.37 inches. Circle your answer. So, we always want to do a quick logic check. If we were to take a meter stick and measure it to see how many inches were on that meter stick, well, we can basically just either take out some sort of a ruler with inches on it. I actually have inches on both sides, and there is exactly that many inches in 100 centimeters. All right. All right, so question mark, how many millimeters in 1/2 a kilometer? So let's start off with 1/2 a kilometer. Either 1/2 or 0.5 will work. Now we need to times by a conversion factor. That allows us to cross off the units we have. We have kilometers, so we need to put kilometers on the bottom, over kilometers. Now we can't get straight to millimeters. We have to go through centimeters and through meters. So we're going to put meters on the top, and then we're going to ask ourselves, there's 1,000 meters in 1 kilometer, so we're going to put 1,000 on the top and 1 on the bottom. Now, we're going to go straight there without actually finding our answer. So now, we're going to cross off kilometers, and now we're in meters. So we need to get the centimeters. So we need to times by over. Let's put meters on the bottom, and let's put centimeters on the top. And we know that there's 100 centimeters in 1 meter. We now can cross off meters, and we're now in centimeters. We need to times by over. We need to put centimeters on the bottom, and we need to put millimeters on the top. So we can cross off centimeters, and we know there's 10 millimeters in 1 centimeter, and we're simply going to multiply. 1/2, 0.5, times 1,000, times 100, times 10 is 500,000 millimeters. Then just a quick logic check. If you were to walk a kilometer and measure millimeters the whole time, you're probably going to get an answer like 500,000. Let's circle our answer. So notice that in the last question, we decided to get our answer and then times again. But in this question, we just decided to continuously times. That's up to you based on mistakes that you make and how comfortable you feel. All right. All right, so 1D, how many micrometers? Micro is a Greek letter, M and U mixed together, called mu. Micrometers in 4 meters. So we're first going to start with 4 meters. So 4 meters times over. Now we're going to put meters on the bottom because we have to cancel those units. And we're going to put micrometers on the top, mu meters on the top. So now we're always going to attach the unit to the base unit. So if we quickly bring up the website, let me take over. We have our conversion factors in measurement near the bottom, whereby we know that kilo is 10 to the 3, the base unit is nothing, centimeters is 10 to the negative 2, millimeters is 10 to the negative 3, and if you want more advanced physics units, we have to go over the physics. But we're not going to do that right now, so I'm just going to tell you what it is. There are 10 to the negative 6, 1 micrometer is 10 to the negative 6 meters, equals 1 micrometer. So we're just going to start by putting 10 to the negative 6 on the bottom only. Now we don't like negative exponents, so we're going to bring it to the top and make the exponent positive. So let's cross it off and put 10 to the 6 on the top. Now 4 times 10 to the exponent 6 is just 4 with 6 zeros after it. So 4 million micrometers. Now micrometers are absolutely tiny, so let's get some units on there, micrometers, and circle our answer. So micrometers are tiny. We're not going to be able to do much of a logic check on this other than the fact that we know that they're tiny, so there's going to be a gigantic number of these in micrometers. And if you actually do on all the formulas, we have all those units on our physics section. All right. So we have 1E. So how many millimeters in 0.00024 kilometers? So if we start off with 0.00024 kilometers and times over, we need to cross off kilometers, so we'll put kilometers on the bottom. We need to go through meters, and we can put 1,000 meters on the top and 1 kilometer on the bottom. Then we can cross off our kilometers, and now we have to cross off meters. So we're going to times by meters on the bottom, centimeters on the top, and let's put 100 centimeters beside centimeters and 1 on the bottom. Then we'll have to go through to millimeters, so times over. Then we can put centimeters on the bottom and millimeters on the top. We can go back a couple steps and cross off meters from the top and the bottom and cross off centimeters from the top and the bottom, and there are 10 millimeters in 1 centimeter. And then if I take 0.000 and multiply it by 1,000, and then multiply it by 100, and then multiply it by 10, I'm going to get 240 millimeters. Awesome, 240 millimeters. Let's circle that answer. So 0.00024 kilometers is a tiny amount. So 240 millimeters is an approximately logical answer. All right. All right, how many yards in 150 meters? What on earth is a yard? So a yard is an American unit, imperial unit, I believe, because the other ones are SI units. Yes, an imperial unit. We need to know, first of all, what the conversion factor is. So I have our conversion factors. Let's get that sheet out open on the website there. So again, same location. We have all of the metric to empirical units that we're going to be using right now. So, let's start off with saying that there are 1 inch is equal to 2.54 centimeters. 1 meter is 3.3 feet. So these are just some of the units that we're going to use. Let's start off with 150 meters on the left there, and times over. So there is a unit for yards into meters on the website, but we're going to do it the hard way. So we're going to convert first from meters into feet. So we're going to erase feet on the bottom. So we need to first of all think, what units do we have? We have meters. We need to cross off those meters. We're going to put them on the bottom first. Then we're going to put feet on the top. We know there's 3.3 feet in a meter, so we can put that on the top. And then we can simply times by another conversion factor, so times over. Remember, again, in the past, we could have done this in multiple steps, but we're going to learn how to do it in one. So notice we have feet. We need to put feet on the bottom. And we need to get to be yards on the top. Do we have a conversion factor between yards? No. We need to go through something else. Let's do it in our heads. So let's go through to inches first. So let's put inches on the top. And we know that there are 12 inches in a foot, either logically or from the sheet. So now let's cross off meters and feet and realize that we're in inches. And now I'm going to check the conversion factor between yards and inches. There are 36. So we can put inches on the bottom, we can put yards on the top, and we can put 36 on the bottom. Notice sometimes the number is on the bottom, sometimes it's on the top. So on the calculator, the process is 150 times 3.3. Some people divide by 1, you don't need to. Times 12 times 1 divided by 36. And we're going to get 165 yards. Should make sense. And let's circle our answer. So keep in mind, there are all sorts of different ways you can do this. We could have gone straight from yards to meters. So let's do that. So let's do this again. So we're going to do this in one step. We're going to fit it on the bottom left-hand corner. We can fit it on the bottom left-hand corner. Perfect. So let's say 150 meters times over. Let's put meters on the bottom. Let's put yards on the top. And there are, this is a meter value, there are 0.9144 meters. And I can take 150 and times it by 1. I don't need to times it by 1. I can just straight up divide it by 0.9144, and we get 164 yards. So let's circle our answer. Now, why are we different? Well, because earlier when we used 3.3, there's not exactly 3.3. And when we use the second time, there's not exactly 0.9144. So there are going to be multiple answers depending on the style that you went for. All right. Okay, so 1G. We have 12 centimeters plus 15 kilometers plus 500 meters equals blank question mark meters. So we need to get everything into meters. So this is the question. So we're going to skip a few lines and start off by converting 15 kilometers, I guess, into meters. So times over. We need kilometers on the bottom. We need meters on the top. There's 1,000 meters in 1 kilometer. And 15 times 1,000 is simply 15,000. We can cross off kilometers, and we can get to 15,000 meters. Keaton, 1,500, 15,000. Sorry about that. 15,000 meters. Now we have to take 12 centimeters. So we're going to take 12 centimeters and times it by over. We need centimeters on the bottom. We'll put meters on the top. There are 100 centimeters in 1 meter. So we're going to have to do 12 divided by 100 is simply 0.12 meters. We can now take both of these answers and put them back up top. So 0.12 meters plus 15 kilometers plus, 15,000 meters plus 500 meters equals, be careful on the size, 15,500.12 meters. And we can circle our answer. That is 15,500.12 meters. So we could have converted them all into different things, but they wanted it in meters, so we're going to convert them all into meters. They might have asked for all centimeters, they might have asked for all kilometers, etc. All right. All right, so 1H. So we have 3 inches plus 6 feet plus 4 yards equals question mark centimeters. So we need to get everything into centimeters. Let's start off with skipping a couple lines and saying 3 inches. Times over. We want to cross off inches, so we're going to put them on the bottom. We want to get to centimeters, we're going to put them on the top. And there are 2.54 centimeters in 1 inch. Excuse me. And 3 times 2.54 is simply 7.62 centimeters. So now we can take 6 feet and we can convert that straight into centimeters. There are 30.48 centimeters in 1 foot. 30.48. Let's erase that. 30.48, or the whole thing. Good. 30.48 centimeters. So 6 times 30.48 is simply 182.88 centimeters. So now we have 4 yards. Now we don't have a conversion factor from yards to centimeters, so we have the option. Let's go through a few things. Let's go through the ones that we know. So let's times by yards on the bottom. Let's go through, so there's 3 feet in a yard. So let's put 3 feet on the top. And then let's just go straight through. So times, let's put feet on the bottom. And let's put 12 inches on the top. And then let's times. Now we're going to have to raise up our math a little bit to avoid that video. So now we know that there are, brilliant, Good. Great. We know that there are 2.54 centimeters in 1 inch. So if I take 4 and I times it by 3 and I times it by 12, 2.54 times by 2.54, we're going to get 365.76. We can write it below. .76 centimeters. Circle our answer. All right. Okay, so we're on to question number 2. Still doing some conversions, but this time in 2A we're doing not distances, but volumes and times and other conversions. So how many liters, question mark liters, in 50 milliliters, ml? So let's start off by, on the margin, 50 milliliters times over. Now, let's start by putting milliliters on the bottom. And we need to get to liters, so we're going to put liters on the top. Now, there's a few different ways we can do this. So we're going to do it in 2 different ways. We're going to start off by doing it the scientific way and then learn how to do it the more simple way. So there are 10 to the negative 3 liters in 1 milliliter. But we don't really like negative exponents. So we're going to bring that 10 to the negative 3 down to the bottom. So let's cross it off and put 10 cubed on the bottom. When we have negative exponents, we can just bring the thing to the top or the bottom and reverse it. So now, 10 cubed is just 1,000. Let's cross off 10 cubed and just write 1,000 in its place. So 50 divided by 1,000 is equal to 0.05 liters. Circle our answer. Does that make sense? Yes. 50 milliliters is a tiny little amount of liquid or whichever, and that's going to be about 0.05 liters. All right. All right, so how many seconds, question mark S, in 1 year? So let's start off with 1 YR on the margin. YR is the units for years, and we're going to multiply by many conversion factors. We're going to times by 365 days in 1 year. We're just going to go straight to it. Then we're going to multiply by 24 hours per day. Then we're going to multiply by 60 minutes in 1 hour. Then we're going to multiply by 60 seconds in 1 minute. Now, first things first, we're going to put IN after M's. So in the last conversion factor, we're going to say MIN. And in the conversion factor right before it, 60 MIN. So we have to use MIN for minutes because meters was taken up by M. So 365 times 24 times 60 times 60 is 31536,000 seconds. Let's insert some commas in there. So starting from the 3 zeros. Good. So we have 31 million seconds in a year. All right. All right. So question mark kilobytes, KBs, in 4 gigabytes, GBs. In 4 gigabytes. So there are some advanced ways to do this, but we're going to go through bytes and then back to kilobytes. So let's start off with 40 gigabytes.
With 4?
4 gigabytes. So times over. Let's put gigabytes on the bottom, and let's just put B on the top for bytes. Now, we need to know how many gigabytes are in 1 byte. Do you know that off the top of your head?
Is it 100?
Gigabytes? So, it's 1,000. Kilo is 1,000. Mega is 1,000,000. Giga is 1,000,000,000. 10 to the 9. So, we're going to put 10 to the 9 attached to the base unit. Good. 1 byte. Good. Equals 4 times 10 to the 9 bytes. We're now going to carry that down to the next line. 4 times 10 to the 9 bytes, spelt B-Y-T-E-S. All good, all good. Good. Times over. So this time bytes are going to be on the bottom. We can use B for the name. And let's get to kilobytes on the top. So there's going to be 1,000 bytes in a kilobyte. So let's put 1,000 on the bottom. I could have used 10 cubed and put 1 on the top. Now if I want to take that number, 4 times 10 to the 9, and simply divide it by 1,000, it will just be 4 times 10 to the 6. KBs. All right. Okay, so we have 2 days. This is 2D. We have 2 days and 13 minutes and 12 hours. 2 days, 13 minutes and 12 hours. Converting it into hours equals question mark hours. So we need to first take 2 days, 2D, times 24 hours in a day, which is 48 hours. Then we're going to take 13 minutes and put minutes on the bottom and hours on the top. And we know there's 60 minutes in an hour, so we'll put 60 on the bottom and 1 on the top. And 13 divided by 60 is 0.21, and the 6 is repeating, 6 repeater. Hours. So now we can take those two answers and put them back above. So let's start off with 48 hours plus 0.216 repeater plus 12 is equal to 60.216 repeater hours. All right, so a quick logic check. Is 2 days, 13 minutes, and 12 hours about 60 hours? Absolutely. Let's circle our answer. Awesome. All right. All right, so question number 3, area and volume. So how many meters, 3A, how many meters squared in 2 kilometers squared? So we have squared units this time. We're going to start by taking our 2 kilometers squared and starting it on the margin, 2 kilometers squared. Now we're going to times by a conversion factor over. We need to cross off kilometers. We need kilometers on the bottom, and then we need meters on the top. And we know that there are 1,000 meters in 1 kilometer. But this only crosses off kilometers. So we're going to cross off kilometers from the bottom, then cross off the squared from the top. We still have kilometers. We need to cross off kilometers and get to meters squared. We have to times by the conversion factor again, times over. We're going to put 1,000 meters over 1 kilometer. And then now we can finally cross off kilometers on the bottom and kilometers on the top. Notice we have meters times meters, which is meters squared, and this is going to be 2 million meters squared. So a quick logic check. A meter squared is the size of 1 meter by 1 meter. 2 kilometers squared is 2,000 meters by 1 meter, or some version of that. A huge amount, so 2 million meters is a very logical answer. Let's circle our answer. All right. All right, so 3B. How many centimeters cubed in 1 meter cubed? So, let's start off with 1 meter cubed on the far left, and we're going to write a little bit smaller than last time so we can fit it all. So we're going to times by 100 centimeters per meter, meters on the bottom, centimeters on the top. Good. Can we just erase that cube? Oh, I see. Yeah. Keaton was trying to do it a faster way. That's a good idea, but we're going to do that after. So we're going to times by 100 centimeters over 1 meter 3 times. Times 100 centimeters over 1 meter times 100 centimeters over 1 meter. And 1 times 100 times 100 times 100 is simply 1 with 6 zeros after it, and we get 1 million centimeters cubed. Let's circle our answer. Now, Keaton came up with a really good idea. So let's go back to the margin. Let's start off with 1 meter cubed. And simply times by 100 centimeters over 1 meter. And then we're going to put brackets around the conversion factor and say cubed. Now, this is just another way. Can you make those three? That's perfect. So those are both cubes. So we're just going to simply do this on the calculator, and 1 times 100 cubed is also 1 million centimeters cubed. So just shorter ways to do it. I never feel as comfortable doing it that way. I always like to do it the way that we did above. All right. Okay, so this time we have a rectangle that let's draw a rectangle and put 2 meters as the width and 3 meters as the length. Notice it doesn't matter where you put them. Now notice the question says it wants in centimeters squared. So we're going to do this in 2 different ways. Yeah, centimeters squared, question mark. We're going to start by converting meters into centimeters. So let's say 3 meters times 100 centimeters per meter equals 300 centimeters. Now in our diagram, we're going to cross off lightly 3 meters, just in our diagram, and we're going to say 300 centimeters. Now we're going to cross off 2 meters in our diagram and just say 200 centimeters because it's the same process. Now we can go back to the margin and say A equals LW, length times width, and down the page A equals 300 centimeters times 200 centimeters equals 6 with 4 zeros after it, centimeters squared. Let's circle our answer, and Keaton, can you please press the type button and scroll up a tad? Perfect. 60,000 centimeters. Now, we could have done it in the above way, and we could have multiplied 3 meters by 2 meters and gotten 6 meters squared, then times it by the conversion factor twice like we did above, but this is a much safer way. All right. Okay, so 3D. Keep in mind, we may have accidentally called the last one D, but 3D. Find the number of cubic centimeters in 1 foot cubed. So cm cubed, question mark, comma, 1 foot cubed. So we're going to need some space. Let's take 1 ft cubed, 1 foot cubed, onto the margin. And we're going to times it by the conversion factor that allows us to cross off the units 3 times. So we're going to times it by 2.54 centimeters per foot 3 times. Again, we could have done the fashion where we just times it by that cubed, but we would much rather do it in the simple fashion. So we have feet on the bottom. Let's cross off a foot and cross off the cubed and say squared. Let's cross off another foot and cross off the squared, and then cross off the foot and cross off the foot. Notice we are at 2.54 cubed. So we're going to take 1 and times it by 2.54 times 2.54 times 2.54 equals 16.4 centimeters cubed. Circle our answer. All right. All right, so we have to find the perimeter and area of these shapes. We're going to start by 4A. We're just going to start by sketching the shape that is given. And notice that it's sort of a couple of rectangles put together. So we're going to put 5 centimeters at the given location, and we're going to put ticks on all the sides that are also 5 centimeters, and then let's put 5 in those locations as well. Just 5s are good. Perfect. So let's start off with the perimeter, P equals. So the perimeter is adding up all the sides. So we don't have the bottom side, but we can clearly see that the 2 top parts are 5, therefore the bottom is 10. Let's put 10 in the diagram, and as well off to the left will be 10 as well. So figuring out this stuff logically isn't too difficult. So now finding the perimeter, let's simply add up all the sides. 10 plus 10 plus 5 plus 5 plus 5 plus 5 simply equals 40 centimeters. Circle our answer. So that's perimeter, adding up all the sides. Now we're going to find the area. So A equals length times width. Now we're going to have many options, but what we want to do is we want to divide the shape. So let's see what Keaton decides. Ooh, straight down. Perfect. So let's start off with the rectangle on the left. We have A equals the length times width. We've identified area 1 and area 2. So area 1 is simply length times width, so that will be down the page. 10 times 5 equals 50 centimeters squared. Now we're going to find A2, the second area, and that length times width is simply 5 times 5, which equals 25 centimeters squared. Now to find the total area, we just simply add up the different areas. So 50 plus 75 equals 50 plus 25 equals 75 centimeters squared.
Oh, 50. Oh, yes.
Yeah, there we go.
Yeah.
Sorry about that. So we're just going to raise the little tad. So that's 50 plus 25 equals 75 centimeters squared. And we can circle our answer. So notice perimeter, the units are just centimeters, and area, the units are centimeters squared. Keep in mind, Keaton, hang tight. What we could do, we could have made a huge rectangle. Then did A equals length times width, which would be 10 times 10, which would be 100 centimeters squared. But then we would have had to minus the area of the red bit, which is 5 times 5, which is 25 centimeters squared. And then if we subtract, we're going to get the same answer, 75 centimeters squared, no matter what. So there's always different ways to do these. All right, so question number 4B. Find the perimeter and area of the following shape. So we have 2 horizontal lines and 2 semicircles touching at the middle. The bottom length is 6 centimeters. So let's start off by saying P equals. So we're going to start off with 6 plus 6. Then we're just going to say plus, and we don't know what's left. So now we have to recognize that we have 2 semicircles. Now the perimeter of a circle is called the circumference, and C equals 2 pi r. Now, what is the radius of this circle? So let's put a dot in the center of the circle, or where it would be, and let's put a radius straight to the left. We can clearly see that the bottom horizontal is 6, and half of that is simply 3. So we can put 3 for the radius. So, down on the formula, C equals 2 times pi times the radius 3, which equals C equals 18.85 centimeters. Now, this is only a half circle, so we have to divide this by 2. So, divided by 2 equals 9.42 centimeters. Now we can take this above where we're calculating the perimeter, 6 plus 6 plus 9.42. Now there's 2 of them, so plus 9.42. This will equal 30.85 centimeters. Circle your answer. So notice earlier we could have, instead of divided by 2, we could have just called it 18.85, the full circumference. No need, all good. So we could have just not divided by 2, and instead of adding it twice, just simply added 18.85 to 12 plus 12. But those are all sorts of different ways that we can do things in faster ways. All right, so for B, calculating the area, we're going to redraw this shape. And we need to find the area of this shape. How on earth are we going to do that? Well, notice it's just going to be a rectangle minus 2 semicircles, which is just a circle. And if we cut that circle in half, it will look much more obvious. So it's a little bit backwards, but that shape is just a rectangle minus a circle. So on the first diagram, let's put 6 on the bottom. And on the second diagram, let's put 6 on the bottom. And we know this is 2 semicircles together, so the other length of the rectangle will be 6. It will be a square. And then in the diagram off to the right, let's put in a horizontal radius of 3 that we calculated before. And we're simply going to find these 2 shapes. So let's find the area of the rectangle below the rectangle. A equals, good enough, A equals LW. Therefore, A equals 6 times 6. Therefore, A equals 36 centimeters squared. Now let's find the area of the circle below the circle. So A equals pi r squared. Just pi r squared, no circumference. Just A equals pi r squared. So down the page, A equals pi times 3 squared. Therefore, A equals 28.27. So now back to the left, A equals, we're going to take the 36 and minus the 28.27. And we're going to get 7.73 rounded centimeters squared. So sometimes it's useful to find areas by figuring out different composite shapes that make that shape in a better fashion. All right. Okay, so how many minutes would it take to fly around the world? Question 5A, how many minutes would it take to fly around the world? at 200 kilometers per hour if the radius of the Earth is 6.38 times 10 to the 6 meters. First thing we have to do is take 6.38 times 10 to the 6 meters and convert it into kilometers. Meters on the bottom, meters on the bottom. We're going to get to kilometers. There's 1,000 meters per kilometer. So that's going to be 6.38 times 10 to the 6 divided by 1,000 is 6 times 10 to the 3, which is 6,380 kilometers for the radius of the Earth. We now need to find the circumference. C equals 2 pi r. Therefore, C equals 2 times pi times that. And the circumference of the Earth is therefore 40,086.7 kilometers. Excuse me, 40,000, yes, 40,086.7 kilometers. I'm going to circle my partial answer and a logic check. Yes, the world has a circumference of about 40,000 kilometers. So now we just have to take that value, 40,086.7, and simply divide it by our speed, 200. We want to figure out how many times 200 goes in. And we get 200.4 times 204 times. So that means if that fits in that many times, then the answer will be 200.4 hours to circumnavigate the globe at 200 kilometers per hour. Okay, so we're now finding unit rates. Mandy drove, this is 5B. Mandy drove 120 kilometers in 2 hours. And we need the unit rate. So that's equal to over 1 hour. Now, how do I get from 2 to 1? I simply divide it by 2. And if I divide the bottom by 2, I have to divide the top by 2. 120 divided by 2 is 60 kilometers. Therefore, the unit rate is 60 kilometers in 1 hour. I've written that a little bit funny on the bottom, in 1 hour. So now we're going to do the reverse. We're going to flip it over. 2 hours in 120 kilometers equals over 1 kilometer. Now, how do I get from 120 to 1? I simply divide it by 120. And if I have the top, 2 divided by 120 is simply 0.016 repeater hours per kilometer. Now, which one of the unit rates is more useful? Well, obviously the one that we want to use, 60 kilometers per hour. So sometimes it's useful to find both. We're going to find both anyways all the time, but great. So, continuing. Devin delivers 45 papers in 2 hours. And we're simply going to get it down to the unit rate of 1 hour. How much can Devin deliver in 1 hour? Well, we're dividing the bottom by 2, so we're just going to divide the top by 2. And we get 22.5 papers per hour. Now, is that a useful unit rate? Not exactly, because we have a decimal and we can't deliver half of the paper. So, a better rate would actually just be 45 papers per 2 hours, but it's not a unit rate, and they were specifically asking for a unit rate. Okay, milk costs $3.2 for a 4-liter jug. and we want to get that down to a unit rate, so over 1 liter, and we're dividing the bottom by 4, so we must divide the top by 4, and $3.20 divided by 4 is $0.80 per liter. But here's an example where we might want to find the other unit rate. So I'm going to flip it over. 4 liters over $3.20 equals over $1. How many liters am I getting for $1? Well, how do I get from 3.2 to 1? I simply divide it by 3.2. Then I have to do that to the top, divided by 3.2. And 4 divided by 3.2 is 1.25 liters. That is also a very useful rate. $1.25, $1.25, 1.25 liters per dollar, or 80 cents per liter. Both extremely useful rates. Okay, Blair eats 1/2 a grape, 1/2 a grape in 1/4 of a second. We can use S for second. So we need a unit rate. Let's figure out how many per 1 second. So how do you get from 1/4 to 1? Well, we simply divide it by 1/4. How do we get from 1/2? Well, we're going to do the same to the top, divided by 1/4. Now, we could just use the calculator, but if you're going to use the calculator, you have to say 1/2, brackets around it, divided by 1/4, brackets around it, equals. But we know with algebra, 1/2, we can simply multiply by the reciprocal. Then we can cross cancel. 4 divided by 2 is 2. So we can replace the 4 with a 2 and a 2 with the 1. And 1 times 2 is 2. So we're going to get 2. So we can put 2 on the top. 2 grapes per second. Again, we could also find the number of seconds it takes to do 1 grape, but it will be very similar. We did it on the last question. So unit rates. A unit rate, we basically just need to get 1 on the bottom. That's it. Unit rates. Okay, so we are now doing 5C. So we're going to convert 100 meters per second into kilometers per hour. And we're going to do this separately. Let's start off by taking 100 meters and converting it. Go for it. So we're going to times it by the conversion factor that allows us to cancel what we want. Yeah, go for it. So we have 1 kilometer every 1,000 meters, and that is 0.1 kilometers. We're then going to take 1 second and convert it into hours by multiplying it by 1 minute every 60 seconds, and then by multiplying it by 1 hour every 60 minutes. And 1 divided by 60 is simply 0.00027 repeater, and we can call that hours, HR. Now we can simply take the kilometer value we got and put it on top. So 0.1 kilometers over 0.00027 repeater hours, and we simply get 360 kilometers per hour. Circle our answer. So there must be a faster way for this one specific thing. So let's say M over S, meters over seconds. Or yes, excuse me, let's take 100 meters per second and say equals over and say kilometers per hour. So if we want to get fast to kilometers per hour from meters per second, we simply times by 3.6. And we know 100 times 3.6 is 360. And if we were to go in the other direction, we would simply divide by 3.6. A good thing to memorize is that the speed on the highway is 90 kilometers per hour. You want to write that one down? Is 90 kilometers per hour. And this is exactly equal to 25 meters per second. I like to memorize that one. It reminds me which way to go. Timesing by 3.6 or dividing by 3.6. But if it's anything that's not exactly meters per second into kilometers per hour, then we have to very carefully individually convert the top and the bottom, then re-put them back on the top and the bottom accordingly, do the division, and get the final answer. All right. Okay, we are estimating. Let's start off with estimating the length of an ant. 6A. Let's call it 3 millimeters. Who cares? Estimating in math is much more about just figuring out a relatively logical answer that is sort of approximate of the value, and we want to start getting better at it, and just practice helps. Okay, school bus, 25 feet. If you said 20 feet or 30 feet or 7 meters, they would all be fine answers. Okay, a pen, 10 centimeters. Someone might have said half a foot. Who cares? A megalodon shark. You might have to Google search these things sometimes, but a megalodon shark is going to be about 60 meters. Okay, the Eiffel Tower. One of the relatively tallest towers. Let's say 2,000 feet. Who knows? You could Google search it and find exactly what it was, but this is estimating. The point is to get it wrong sometimes. Okay, Mount Everest. I'm going to go for 8,000 meters. I think that's approximately correct. I know it's about 30,000 feet, but I think it's about 8,000 meters. Okay, distance to the moon. Okay, we're going to have to write that below it. Let's go for 250,000 kilometers. That's not that accurate. I just know that it's 250 million miles to Mars and that it's about 1/10 that distance. Okay, so let's go for seconds in a week. How about 1 million? Who knows? Close. I think it's actually. I think it took YouTube Mr. Beast 11 days to count to 1 million. So I'm not exactly sure. So 1 million in a week sounds about right. Nanoseconds in a minute. So nanoseconds in a minute. Well, 1 nanosecond is 10 to the 9 or 1 billion. So it would have to be 60 of those. So 60 billion nanoseconds, NS. Okay, so that's estimation. So, all right. I figured. All right, so now it says, how long is this S? Well, Keaton's going to pretend like he's measuring it on the screen. And that's exactly what you would do. You'd take out a piece of string and you'd measure it. Notice that it's going to be different based on how much we zoom in or out. But what I want you to do is I want you to print off these notes and actually measure it like it'd be on a test. Oh, good enough. Yeah, so Keaton's just pretending like he would measure it. You've got to measure it with a curved thing like an S. Then you've got to straighten out the S so it's flat. And then, Keaton, why don't you just draw out how long the S would be, how long the string would take up flat. And then we would take out a regular ruler or just measure the string right up to the ruler, and we're going to get 8.4 centimeters if this is printed off on a regular piece of paper. Okay, reading a caliper. Number 8. So, let's zoom into that caliper. So, What we first want to do is find the measure on the small caliper at the far left, then find the measurement on the big caliper, then find out where the two calipers meet, and that's the next decimal. So again, we're going to start off to the left of the small caliper at the first measurement, to the left on the big caliper, which is 2.4. So let's say 2.4. Then we're going to find out where the caliper meets, and this time read the small caliper. So where the caliper meets is at exactly 0.06. Then therefore the final answer, let's do it separately, 2.46 centimeters. Circle our answer. So that one you just have to be careful with. I knew that the small caliper was 100ths because the big caliper went to tenths. So that's going to be a little bit of logic. All right. All right, so let's do question number 9, scales and ratios. So find the ratio of length to width. So we're going to have 3 horizontals by 1.5 verticals. Now the reason why I did that because I want you to print these things off and actually measure them. So we're going to put 3 centimeters by 1.5 centimeters. And we're going to set up the ratio, 3:1.5. Now we can't have decimals in our ratios, so we can simply divide both sides by 1.5, and we're going to get a ratio of 2 to 1. Let's circle our answer. As expected, one side is double the other. Okay. Okay, 9B. So this time we have a 2 centimeter by 2 centimeter inside a 4 centimeter by 4 centimeter. I've measured it on paper. And we can call the side lengths 2 and 2 and 4 and 4. And we can set up the ratio. So go for it. So we're going to set up 2:4. And we're going to simplify that ratio, simply dividing both sides by 2 and get a ratio of 1 to 2. Circle our answer. All right. Okay, find the ratio of a quarter's diameter to a credit card's long side. So if we quickly sketch a quarter, and if we take out a quarter and measure the diameter of a quarter, we're going to get approximately 2.5 centimeters. And then we're going to take out a credit card and get approximately 8.5 centimeters. And we can set up our ratio. So let's say 2.5 centimeters colon 8.5. Now what are we going to divide both sides by? Well, we know that they can both have a 0.5, so we can divide both sides by 0.5. And 2.5 divided by 0.5 is 5. And 8.5 divided by 0.5 is 17, and we can circle our answer. All right. Okay, so number 11. If a scale is 800 to 1 of a totem pole, we can draw a big totem pole, a little rectangle, and the model is 2.5 centimeters. Let's set up let's set up ratio equals ratio. So let's say 800:1. Now, below it, we're going to set up another 2 colons for 2 dots. Now we want to decide, is the 2.5 like the 1 or is it like the 800? Well, we know it's like the 1, so we're going to put 2.5 below 1. Now, how do we get from 1 to 2.5? Let's put an arrow from 1 to 2. Let's go, yeah, sure. Let's go from 1 to 800. We times by 800. Now, if we're going to go that direction, we're going to go in the bottom that direction as well, and times by 800. And 2.5 times 800 is 2,000. So, 2,000, let's put centimeters below it and circle 2,000, or just write the final answer, 2,000 centimeters, somewhere on the page. Does that seem realistic? Absolutely. All right. Okay, number 12. If a scale drawing of a rectangular living room is 2 inches by 3 inches, and we have a ratio of 80:1, which is a length ratio, be careful. And then we can draw a larger rectangle. And if the ratio is 80:1, we can simply times by 80. So 2 times 80 is going to be 160 inches. And 3 times 80 is going to be 240 inches. Now it's saying, what is the area of the actual living room in square feet? So we're going to start by taking the formula for area, A equals LW, and we're going to multiply or substitute in A equals 240 times 160, and we're going to get 38,400 inches squared. Now notice it asks for square feet, so straight to the right of that answer, times. So there are, it's 1 foot every 12 inches, so times 1 foot over 12 inches, and we have to do that twice. So I need to take my answer. Keaton is on the lazy method, awesome. So remember we did those earlier. So I'm going to divide it by 12, and divide it by 12 again, or divide it by 12 squared, and we're going to get 266.7 feet squared. And let's circle our answer. So some of you may have been thinking, why didn't we find the area first? Let's try that. So below, let's say A equals LW, and then let's multiply those together. So A equals 3 times 2, which is equal to 6 inches squared. Then if we convert that, let's times that by 1 foot over 12 inches, twice, represented by squared, 1 foot over 12 inches. And we're going to get 6 divided by 12, divided by 12, and we're going to get 0.0416 feet squared. Then we're going to now times that by 80. And we get 3.3 feet squared, which is obviously not the answer. If they give you a ratio of lengths, you have to convert the lengths first, then it's good. Keaton, can you cross out all that work down below? But we tried it, and some of math is just about trying and figuring it out. I actually didn't know until I tried both and fully understood that if they give you a ratio of lengths, you have to convert the lengths first and then convert it into feet squared. All right. All right, number 13. 12 Christmas cookies takes 1/2 a cup of sugar. And we're wondering how many cups in 54 cookies. So we're going to put 54 Christmas cookies on the left of the colon and ask ourselves, how do we get from 12 to 54? And we're just simply going to divide bigger divided by smaller. 54 divided by 12 is 4.5, so we're timesing by 4.5. Then if I take 1/2 and do the same operation, times 4.5, 4.5 times 1/2, let's do that as fractions. 1 over 2 times 4.5. Well, 4.5 is simply 4 and 1/2. Therefore, multiply bottom times left plus top, 9 over 2. 9 over 2 equals 9 over 4, which is equal to 2.25 cups. And we can put that answer in our ratio. All right, number 14. Aya ate 3 pieces of pizza with 5 pieces left. So let's set up a diagram. Question number 14. So if she ate 3 pieces and there's 5 left, that means that there are 3 plus 5 equals 8 total pieces of pizza. And we want the ratio of pieces to total. So we had 3 pieces eaten to a ratio of 8 total. Remember, we can have part-to-part ratios, part-to-total ratios. Just be careful what they're asking for. All right, number 15. So in a classroom, we have 7 boys to blank girls to 21 total. And we're wondering, if we have 420 total students in the class, how many boys and how many girls? Well, first of all, if there are 21 total in the first, then we can simply do 21 minus 7 to get 14 girls. Makes sense. 7 plus 14 is 21. Now, how do we get from 21 to 420? Well, we just do the bigger 420 divided by the smaller 21, and we're simply timesing by 20. So we can take 7 and times it by 20, and we're going to get 140 boys. And if we take 14 and times it by 20, we're going to get 280 girls. And 140 plus 280 is equal to the total. So again, we can have part-to-part ratios and part-to-total ratios, or part-to-part-to-total ratios. So at the end it says find all part-to-part and part-to-total ratios. So we have 7 boys to 14 girls. We also have 7 boys to 21 total. And we have 14 girls to 21 total. Now, should we bother with the bigger ratios? No, because they're going to simplify to these ratios as well. You may want to further simplify the ratios. 1 boy to 2 girls. 1 boy to 3 total. Or 2 girls to 3 total. Simplified part-to-part and part-to-total ratios. Okay, so 15B, a little bit more on marble ratios. So we have 3 red to 5 blue to how many total? Well, 3 plus 5 equals 8. So we have 8 total. And then we want the ratio, if we know we have 35 blue, how many total and how many red? Well, we ask ourselves, how do we get from 5 to 35? And we'll do bigger divided by smaller. 35 divided by 5 is 7, so we're multiplying by 7. And 3 times 7 is 21 red. And 8 times 7 is 56 total. And just to confirm, 21 plus 35 equals 56. So we have our final ratio. Again, it says find all part-to-part and part-to-total ratios. So we have 3 red to 5 blue. And we have 3 red to 8 total. and we have 5 blue to 8 total. So part-to-part ratios, part-to-total ratios, and part-to-part to total ratios. Be careful with those. All right, so if a scale on a map, we're just going to draw a rectangle to represent a map, and below we're going to write the scale is 1 to 50 million. So that's 50 with 6 zeros after it. 50 million is the distance on the map. So, and the distance on the map between Vancouver, let's put a V and then a dot for C. And that distance is 2.1 centimeters. What is the actual distance? So we have a map out in front of us and we're measuring it with a ruler and we get 2.1 centimeters and we have a ratio. So directly below the ratio we've already written, we can put 2.1 on the left because it's the smaller. Then we can ask ourselves, how do you get from 1 to 2.1? Oh, sure. Okay, let's go that way. So how do you get from 1 to 50 million? We times by 50 million. So we'll just simply take the 2.1 and times it by that. And 2.1 times 50 is 105 with 6 zeros after it. Circle only our answer. So, what are our units? Well, our units are in centimeters. We have to take that number and convert it into kilometers because that's what the question asked for. So let's take 105 million centimeters and times it by the fraction of 100, 1 meter over 100 centimeters. Oh yeah, we're not going to go through kilometers. We're going to go through meters first. So times by 1 meter over 100 centimeters, and then again times by, go for it.
Is it
1 kilometer and 1,000 meters. And if we take that, and we're just going to actually do the algebra. So Keaton, if you can please cross off 5 zeros from the bottom. And there's our answer, 1,050 kilometers. Circle our answer. Now, is that a good logic check? Yes, it's absolutely approximately 1,050 kilometers from Vancouver to Calgary. We are good. All right. Okay, fits into number 17A. So how many 3-inch pencils, I'm going to draw a little pencil and call it 3 inches, fit into the length of a meter stick? So we either need to convert meters into inches or inches into meters. Let's convert 1 meter into inches. So 1 meter, 1 meter times over. So we need to know how many inches there are in a, I can do this in my head. So 1 meter, I'm going to convert to feet. So there are 3.3 feet. Every 1 meter, cross off meters. Then we're going to times it by 12 inches per foot. So 3.3 times 12 times 1 is equal to 39.37 inches. Then we can simply divide that by 3 inches and find out the answer is 13.1 pencils. Circle our answer. A quick logic check. Yes, if you take out a bunch of pens or pencils and move them along a meter stick, you're going to get about 13.1. So we have 17B. How many 1 foot square tiles needed to floor a 300 centimeter by 200 centimeter room? So we're just going to sketch a little 1 foot square. Then we're going to sketch a bigger diagram being 300 centimeters by 200 centimeters. Like we did before, we're going to convert these separately. So let's take 300 centimeters and times it by 1 foot over 30.48 centimeters, and we get 9.84 feet. Then we can take 200 centimeters and times it by the same conversion factor, 1 foot over 30.48 centimeters. And we will get 6.56 feet. We can then write A equals LW, and we can multiply our length, 9.84, by our width, 6.586, and we get an area of 64.57 feet squared, meaning that that is our final answer, and we can fit 64.57 of those little square tiles into to floor our room. Awesome. All right, 17C. How many 335 milliliter pop cans can fit into a 4-gallon bucket? So let's take 4 gallons on the margin, 4G, and times it by a conversion factor. So we're going to have 1 liter on the top and 0.26 gallons on the bottom. And we take 4 and we divide it by 0.26, we get 15.38. And that's going to be liters. Now we could convert that into milliliters, but we'd rather take 335 and turn it into liters. So 335 milliliters times 1 liter over 1,000 milliliters equals 0.335 liters. Now we can simply do a division. So we can take 15.38 and divide it by 0.335, and we're going to get 45.9 is our final answer. So it's a little English sentence maybe, pop cans, circle your answer. Great, so approximately 46 pop cans fill into a 4-gallon. Keep in mind, I could have used a different conversion factor above, like 4 liters per gallon. We also have to be careful whether or not it's like metric gallons and it gets weird. So we won't go that far. We'll stick to our unit that we use. Your teachers will give you formulas that you're going to be using. All right. Okay, 17D. So 4 liters covers a 200 square foot wall. So how many liters of paint in order to cover 50 square meters? So question mark liters, colon, meters squared. Oh, 50 meters squared. So first thing we want to do is we're going to want to convert. Well, we can convert it in so many different ways, but let's go from meters squared to feet squared. So let's take 50 meters squared and multiply it by a conversion factor. That's going to allow us to cross off the units we have and get to the units we want. 3.3 feet per 1 meter. Cross off our meters and only our squared. Then we're going to times by the unit conversion factor again. This time we can cross off meters and meters. We're left with feet times feet, which is feet squared. And 50 times 3.3 times 3.3 is equal to 544.5 feet squared. So, if that's true, then we know that 4 liters covers 200 feet squared. Therefore, how many cover 544.5 feet squared? I forgot to square the 200 on the bottom left. So we just say, how do we get from 200 to 544, and we simply divide by 2.7. So if I'm going in this direction, I'm going to times. Excuse me, my mouse is times 2.72, and I'm going to do the same thing to the top, times 2.72, and that number times 4 is 10.89. Therefore, it will take 10.89 liters to cover 50 meters squared. All right, number 18. How many liters, question mark liters, can fit in this cube? If anyone doesn't know how to draw a cube, we draw a square, we put a dot in the center, and that's now the bottom left-hand corner of the next square, and we connect our corners. Now, each length is 10 meters. We know because it's a cube. So let's start by converting 10 meters into centimeters. So 10 meters times 100 centimeters per 1 meter equals 1,000 centimeters. Crossing off our meters, getting to centimeters. Now the formula for the volume of a cube is length times width times height, or s cubed or something, but basically multiplying 1,000 together 3 times to get 1 billion centimeters cubed. So we know that 1 centimeter cubed by definition is equal to 1 milliliter. So we can just get rid of our centimeters cubed units and write milliliters cubed. So now we need to convert that into liters. So if we take 1 billion milliliters, we have a conversion factor. We know that there are 1,000 milliliters on the bottom over 1 liter. So I can cross off 3 zeros from the top, 3 zeros from the bottom, and I'm left with 1 million liters. So 1 million liters can fit into a 10 by 10 by 10 meter cubed. All right. Okay, number 19. Find the velocity, v equals question mark, of a wheel, a circle with radius of 20 centimeters, which turns 8 times per second. 8 turns per 1 second. So this happens for 1 minute. And we're wondering how many turns. So, first things first, find the velocity. So, we're going to start by finding the circumference of the wheel. C equals 2 pi r. C equals 2 times pi times a radius of 20. Therefore, on the calculator, if we take 2 and times it by pi and times it by 20, we're going to get 125.66 centimeters. Therefore, the wheel has a circumference of 125.66 centimeters. Now, if we do 8 turns in 1 second, if we do 8 turns, well, we can simply times that by 8, and we can get 1005.3 centimeters. Meaning, if the wheel has a circumference of 125 and it turns 8 times, the distance that we're going to have gone is that. And our velocity can simply be that per second. About 1,000 centimeters a second is our velocity. Now it says how many degrees does it turn in 1 minute? Notice the 1 minute didn't contribute to the velocity. So how many degrees does that turn in that time? Well, we'll want to remember that if the wheel turns 1 time around, that's 360 degrees. So we need to figure out how many turns it does. Well, if we take 8 turns per second, and we're going for 60 seconds, 1 minute, we can simply times by 1 minute or 60 seconds, which will get us 480 turns. Now, if we do 480 turns, and we multiply it by 360 degrees, the value of 1 turn, we're going to get 772,800 degrees. The wheel will turn 172,800 degrees in 1 minute or 60 seconds.